We are about to embark on a super huge journey, but yet a very exciting one because we are going to build together a series of machine learning models from all the branches of machine learning. Hello everyone and welcome to the data pre-processing and action part of machine learning with Python. My name is Narendra Kumar Sharma. Data pre-processing is the first very important step of this journey because anytime you build a machine learning model, you always have a data pre-processing phase to work on. You have to pre-process the data in the right way so that the machine learning model that you are going to build can be trained the right way on the data. So we have to start with this step. I'll make sure to do this very efficiently so that we can rapidly proceed to the branches of machine learning where we are going to build some models. But before that, we have to learn data pre-processing. And that is exactly what we are going to do in this lesson. You can use Google Colab or Jupyter Notebook or Visual Studio Code setup for Python development for your implementation. Feel free to use environment you like the most for this implementation. We have this data in a CSV file, data.csv, which is the dataset on which I'll show you how to implement data pre-processing tools. And just to give you some context, let's say that this data belongs to a retail company that collected some data from their customers, whether or not they purchased a certain product. So here each of the rows correspond to a different customers, and for each of these customers this company gathered their country, their age, their salary, and whether or not they purchased their product. So that's a simple data set. Now I'll explain the data preprocessing steps and tools. That's the whole structure of the implementation. So let's have a look at them one by one. So the first thing I'll show you is how to import libraries. Then I'll show you how to import the dataset. That's exactly the same dataset which I just introduced to you a few seconds ago, data.csv. Then I'll show you how to take care of missing data. Because in most of the datasets you will work with in machine learning projects, you might encounter some missing data. And that is the case here for our dataset. As you can see, there is a missing age here and a missing salary here, and I'll show you exactly what to do in order to handle this. There are some techniques which are the most relevant to optimize the training of your machine learning models, and I'll show you the best of these techniques. Then after taking care of the missing data, I'll show you how to encode categorical data, whether it is the independent variable, which is your predictors, or dependent variables, which is what you want to predict. So as you can see in our data set, we have actually two categorical variables. We have this one, the country column containing three categories, France, Spain, and Germany, as opposed to all these numerical values, okay, in all other variables. And also we have this categorical variable containing two categories, yes and no. I'll show you what to do with that situation so that you can be ready to pre-process any data. After this, I'll show you how to split the data set into the training set and a test set. And that step is very important because each time you want to train a machine learning model, you have to create two separate sets. One training set where you are going to train your machine learning model to understand the correlations inside your data set, and one test set that you are going to use to evaluate your machine learning models. The test set is like new data on which the model was not trained. So that's very important to do this in order to check that there is not overfitting when your machine learning model is trained too well on the training set, so well that it doesn't perform well on new observations. And finally, I'll show you a very important tool that you might have to use in some of your machine learning model implementations, which is feature scaling, which actually scales all your features to make sure they are on the right scale. You won't have to use that all the time. We will see, of course, in each of the machine learning model implementation, whether we have to apply feature scaling or not. All right, so that's the whole structure of the implementation, and we are going to implement each and every one of these tools from scratch. These are all the tools that you'll probably need when pre-processing your future dataset for your future machine learning models. So it is very important that you understand well this implementation. Now we are going to implement the very first step of this process, which is the importing libraries. It is actually very simple. We are going to import three libraries now, which are NumPy, Matplotlib, and Pandas. NumPy will allow us to work with arrays. Then we will import Matplotlib, which is the library that will allow us to plot some nice charts. You will see that we will plot actually many charts and graphs in this series. And finally, Pandas, which will allow us to not only import the dataset, but also create the matrix of features and the dependent variable vector. So let's import these libraries. Importing a library in Python is very simple. Importing the libraries and add a code cell. We start with import. It allows us to import and use functions, classes, and variables from other scripts. The import statement is the most common way to bring external functionality into our Python program. A library is a collection of modules containing functions and classes with which you can perform some actions and operations. Then you need to follow the name of the library you want to import. The first one we want to import is NumPy. And then what we usually do is we add a shortcut, because each time we will use a function of the NumPy library, we will have to call NumPy first. And in order to call it faster, we can add a shortcut here, so that each time we want to call NumPy, we will actually call it with its shortcut. And the shortcut we usually use for NumPy is NP. And to add a shortcut, you simply need to add as and then the shortcut name NP. Every time we will call NumPy, we will actually use NP. Then import next library. The next library is Matplotlib. Matplotlib is typically used with the PyPlot module. We are going to import particularly the PyPlot module. Import matplotlib.pyplot as PLT. The shortcut name is PLT. And finally, we are going to import the Pandas library, a super useful library to pre-process your dataset and mostly to import them. Import Pandas as PD. Now you know how to import the libraries. Now we are going to move on to the next step, which will be to import the dataset. We are going to import the dataset data.csv file. Okay, we are going to learn how to import that CSV in Python using the Pandas library. The first thing we have to do is to create a new variable, and this variable will contain the dataset. I'm going to call this variable dataset. So add a new code cell and use variable dataset. So what will this variable be equal to? It will be equal to the output of a certain function of Pandas. We are going to call a certain function by the Pandas library, which is called read_csv. And this function, we will only have to input the name of the dataset file name with the extension. The first thing we have to do is call the Pandas libraries. So pd dot read_csv. You have to input in quotes the name of the dataset file name. So in quotes, this dataset.csv file is in data folder. So data folder and data.csv file name. And then if you want to view dataset, okay, you can use head function, head method. So dataset.head. The head method in the Pandas library is used to return the first rows of data frame or a series. It is primarily used for a quick preview of the dataset structure and contents without loading the entire object into the memory. It returns the first 5 rows by default. So to view the data, run first cell, click this button, to run this cell, and this number here, it is 1. Okay, it shows that the cell executed successfully, and then execute this cell, and it is showing data here, data from the data set. So there are 4 columns: country, age, salary, and purchased. The next thing that you have to do is create 2 new entities. The first one is the matrix of features, and the second one is the dependent variable vector. Now I am going to give you a first very important principle in machine learning. The features are the columns with which you are going to predict the dependent variable. In this data set, this country, age, and salary are features, and this purchased is dependent variable. This company would like to predict if some future customers are going to purchase a certain product based on given country, age, salary information. The features are also called the independent variables, are the variables containing some information with which you can predict what you want to predict. Now we want to create the 2 entities. First, the matrix of features containing separately country, age, and salary columns, and separately we want to create the dependent variable vector containing only the last column, because that's the column we want to predict. And we are going to call the matrix of features X and the dependent variable vector Y. And in order to create X, we simply have to take the first 3 columns of this data set. So that is country, age, and salary. So what we are simply going to do is play with the indexes to collect the columns data. The indexes of the first 3 columns, basically all the columns of the data set except the last one. So let me show you how to do this. Let's add a code cell, and here X equal to, we have data in dataset variable, dataset dot use ilog property, ilog, and we want all rows from the dataset, and we want all columns except the last one. Okay, so here we are specifying, actually we are using range, okay, to specify what rows and columns we want to extract, okay, get from the dataset. Dot values. We are specifying range of rows and columns here. So a range in Python includes the lower bound but excludes the upper bound. So, and therefore here we are excluding this index minus 1, meaning the index of the last column, and therefore what this will do is it will take all the columns excluding the last one, and that's exactly what we want for our matrix of features. And now let's do the same for our dependent variable vector, and this will be the exactly same. So we can, I'm going to copy and paste this. Paste here. Variable name is y, dataset.ilog. So we want all rows from this column, all rows, and only the last column, so -1 dot values. Now I'm going to show you the X and Y will be well created, and in order to do this, use print function, add a code cell, print X, add one more code cell, print Y. Run this cell. Now run this cell in order to print the matrix of features X, and now it is showing the data of these 3 columns: country, age, and salary, and this is matrix. And now let's run this cell to print Y, the dependent variable vector. Run. It gets the dependent variable vector containing all the decisions whether or not the customers purchase the product. We now have our matrix of features X and our dependent variable vector Y. We need these 2 entities to build machine learning models. Now we are going to proceed to the next step, which is a new tool which I'm going to show you, and that will take care of missing data. Many real-world datasets contain missing values, often encoded as blanks or nans. In our dataset, we have seen that there is a missing salary for a customer from Germany, age 40 years, and who purchased the product. So this is fifth row. In this vector, fifth value is yes. So this customer purchased the product. And there is a missing age for a customer from Spain. Salary is 52,000. Age is missing. And for this customer, this is seventh row. So this customer did not purchase the product. Generally, we don't want to have any missing data in our dataset for the simple reason that it can cause some errors when training our machine learning model, and therefore we must handle them. There are actually several ways to handle them. A basic strategy is to discard entire rows or columns containing missing values. However, this comes at the price of losing data which may be valuable. A better strategy is to infer the missing values from the known part of the data. This is what we are going to use right now, actually replacing the missing values by the average of all the values in the column in which the data is missing. This is a classic way of handling missing data. Let's create a new code cell. So for this step, taking care of missing data, insert a code cell, and let's replace that missing salary by the average of all the salaries and missing age by the average of all the ages. And to do this, we are going to use a library, one of the best data science libraries, scikit-learn. It contains a lot of tools, including a lot of data processing tools. And to do this, the class that we are going to use from scikit-learn is called SimpleImputer. The SimpleImputer class provides basic strategies for imputing missing values. Missing values can be imputed with a provided constant value or using the statistics, mean, median, or most frequent of each column in which the missing values are located. We are going to first import the SimpleImputer class. Then we will create an instance of the SimpleImputer class. This object will allow us to replace missing salary by the average of the salaries and missing age by the average of ages, and then we will have an updated data set, an updated matrix of features, because we will apply this imputer on the matrix of features only. So we will have a new matrix of features with no missing data. Let's do this. Since the class belongs to scikit-learn, which has the name sklearn, so from sklearn, the SimpleImputer class which we want to import belongs to impute module of scikit-learn. Impute. From this impute module, we are going to import the SimpleImputer class. Import SimpleImputer. Then create an instance of this class. Use a new variable, imputer. To create instance, simply call the class and add parentheses. So SimpleImputer and add parentheses. Then input the arguments. First, we have to specify which missing values we have to replace. So missing values equal to np.nan, because we want to replace nan. Then specify strategy. The strategy that we want to use is mean. Okay, we want to replace missing values with average. Instead of replacing missing values by the average of values of that column, you could replace them by the median of values. You could also replace a missing value by the most frequent value, the most classic one, and the recommended option is the average, the mean. Then call fit method on imputer. Imputer dot fit input matrix of features X with all the rows, with all rows, so column, and columns containing missing values. So in our data set, age column index 1 and salary column index 2 have missing values. So pass 3. Okay, because the upper bound is excluded. The fit method in simple imputer is used to calculate the statistics from the provided data set that will later be used to fill in missing values. The next step is to call transform method on the imputer. Imputer dot transform. Pass X with age and salary columns. So we can copy this because we want to pass all rows and same age and salary columns to transform to operate on. The transform method is used to replace missing values in a data set with calculated statistics, estimated values. It relies on statistics already calculated during the fit stage. Then we need to update the age and salary columns index with the age and salary missing values replaced. Copy this and assign the return result, okay, to X all rows and first and second column. Now we are going to check the updated matrix of features X, and to do so we are going to create a new code cell where we are going to print the new matrix of features. So add a new code cell and print updated X. Run this cell. This number shows that the cell executed. Now run print X. We can see here nans are replaced in this new version of X. Next tool in the toolkit is to encode categorical features. We will implement rest of the tools in the next video. If you enjoyed this video and want to see more like this, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below. I look forward to seeing you back in the next video. And until then, enjoy machine learning.